And we'll start first with the first group of side chains, because we're going to break these up, and these are the R groups that I mentioned to you. And the first group, of course, are simply hydrocarbons. And I'll start by showing you for the first or second amino acid the general structure. Again, I'm drawing them in the Zwitter ionic form because we all agree that that's what amino acids are going to look like. And glycine is the easiest of all of them. Gly, G, easy. Something special about this alpha carbon compared to every other alpha carbon of an amino acid of the 20. What's special about this one? Yeah, it's achiral. It's not chiral, right? Because it's got two of the same substituents. Okay? I'll draw one more like this, and then I'm going to stop drawing the amino group and carboxyl group, and I'm only going to focus after this then on the alpha carbon and below. And if this is a methyl group, this is called alanine, ALA. It goes by the single letter code A. Okay, and I'm just going to draw for you now what the side chains are. Okay? So if everyone's okay, I'm just going to draw the alpha carbon like this. I'm not going to draw the amino and carboxyl groups anymore. Okay, and I'm only going to draw now the side chain. This one looks like the upside down letter V. This is that side chain, and this is called valine, single letter code V. Nothing tricky so far. Okay. I can do the same thing. And now I can do the exact same thing I did before. The only difference now being that I have extended that letter V by one methylene group, and this is called leucine, LEU, single letter code L. Now I can draw an isomer of leucine that looks like this. Okay. Again, I'd like you to notice that the side chain here contains the exact same number of carbons, 4, as the leucine side chain, but it's an isomer of leucine, and so we'll call it isoleucine, ILE, or single letter I. Now, there's something a little curious about isoleucine. What's special about this carbon? Yeah, it's chiral. It's also chiral. So I have two chiral centers, the alpha carbon and this. Okay. There's one more hydrocarbon-based side chain that I need to tell you about, and it's a little bit of a funny amino acid, and we alluded to it already the last time. And that's because this time I'm going to have to draw it a little funny. So here's the nitrogen, hydrogen. Here's my alpha carbon, COO minus, NH. 2 plus. And that's because this side chain comes around. This side chain isn't free-floating. It's 3 carbons that rejoins this nitrogen here. And so, in fact, even though I told you that there were 20 amino acids, I lied. Because this is really an amino acid. Although we will forever after refer to it incorrectly as an amino acid. And this is, of course, the amino acid proline, which goes by the single letter code P. Okay, and the side chain for the proline, again, is these 3 carbons. This is the one, remember, that I alluded to was more likely to form a cis-proline bond. Now remember, it's still going to primarily form trans-peptide bonds. But if any amino acid has a tendency to form cis-peptide bonds, it's the prolines. Okay.